Welcome to The Explainer. So, today we're looking at what honestly feels like a massive shift happening right now in the AI landscape. For the longest time, the accepted narrative has been pretty simple, right? It was that proprietary closed source models were essentially your only real options for truly complex enterprise grade coding and security tasks. But a brand new open weight model from Zhipu AI is completely shaking up that assumption. And the data we're about to go through is genuinely fascinating. We're going to break down exactly how GLM 5.2 is stepping up and challenging the big players. Right off the bat, I want you to focus on this number, 39%. Now, in the wild world of automated vulnerability detection, that is a massive, massive deal. This represents the F1 score that GLM 5.2 just achieved on Semgrep's incredibly rigorous IDOR benchmark dataset. IDOR stands for Insecure Direct Object Reference, by the way. To put that into perspective, detecting these kinds of vulnerabilities requires an AI to not just blindly read code. It literally has to deeply understand complex authorization logic stretching across multiple files. It's a notoriously difficult puzzle to solve. Okay, let's dive into this. Here is our roadmap for today's explainer. First, we'll look at how GLM breaks benchmark records. Next up, under the hood architecture. Then, open weight versus proprietary costs, followed by the AI coding ecosystem, and finally, upgrading and getting started. Kicking things off with Section 1, GLM breaks benchmark records. Now, what's really interesting about this is that we aren't just looking at some minor incremental update. It's a massive leap forward. Look at this direct comparison. GLM 5.2's 39% F1 score completely overtakes Claude Code's 32% on the exact same Semgrep IDOR benchmark. It's a classic David versus Goliath victory, really. You have an open weight model outperforming a top-tier proprietary coding agent on a highly specialized cybersecurity task. Oh, and here's a wild detail from the report. At this performance level, GLM 5.2 is identifying these vulnerabilities at an approximate cost of just 17 cents per vulnerability. No way, right? But you know what? Its victories extend way beyond just cybersecurity. GLM 5.2 actually just took the #1 spot on Design Arena's single-round HTML web design leaderboard. It hit an ELO score of 1360, which entirely outperformed models like Claude 5, Opus 4.6, and Opus 4.7, based on real crowdsourced human voting. Fun fact from the data too, GLM 5.2 has this massive preference for modern frameworks, opting to use Tailwind CSS in 91% of its designs. And on top of the whole shebang, it's absolutely dominating standard coding benchmarks, scoring an 81.0 on Terminal Bench 2.1 and a 62.1 on SWE Bench. Moving right along to Section 2, under the hood architecture. So, to really grasp how it's pulling this off, we've got to look at the technical engine. The secret sauce here is absolutely something called a mixture of experts, or MO, architecture. If you aren't familiar with it, MO is an AI design that doesn't just fire up the whole brain of the AI for every single little task. Instead, it cleverly routes specific tasks to specialized subnetworks, or, experts. This drastically saves on computational power while maintaining incredibly high reasoning capabilities. It's super efficient. The efficiency gain here is just staggering. GLM 5.2 is a massive model. We're talking boasting approximately 750 billion total parameters. But because of that MOE architecture we just talked about, it only activates around 40 billion parameters per token during inference. So what does that actually mean for us? It means you are getting the immense reasoning power of a 750 billion parameter behemoth, but the single forward pass computation is much, much lighter. Now, combine that efficiency with this. A 1 million token context window. Wow, that is a huge upgrade from its previous 200,000 token limit. But why does this matter so much, especially when we talk about cybersecurity? Well, because detecting complex vulnerabilities requires an AI to analyze code across multiple files and understand huge, large-scale authorization frameworks. A 1 million token window basically allows developers to feed entire massive project structures directly into the model without any substantial truncation. It dramatically minimizes those annoying false negatives that pop up when an AI simply forgets cross-file references. Which brings us to Section 3, open weight versus proprietary costs. And this brilliantly illustrates the serious economic paradigm shift we're seeing right now. Just look at the API pricing per million tokens. GLM 5.2 sits right around $1.40 for inputs and $4.40 for output. Now compare that directly to Claude 5, which comes in at $10 for input and a whopping $50 for output. When you're doing vulnerability scanning at an enterprise scale or generating automated design code non-stop all day, These cost differences literally make previously impossible automated workflows completely economically feasible. Furthermore, we really have to consider the licensing here because, as this quote from the source material points out, GLM 5.2 utilizes the highly permissive MIT license. This is absolutely crucial for enterprise security teams. It completely mitigates vendor lock-in and means you can deploy these exact model weights locally or right in your own private cloud. You could even fine-tune the model for your specific, highly classified domain security policies without ever having to send your sensitive data to a third-party API. Let's pivot to Section 4, the Z.AI coding ecosystem. Now, if you aren't deploying locally, ZAI offers a structured coding plan to access GLM 5.2 with some specific guardrails for fair usage. Across their Lite, Pro, and Max tiers, the prompt limits are really the key thing to watch. For example, the Max plan gives you roughly 1,600 prompts every 5 hours. Keep in mind, though, one prompt isn't just a single API call. Under the hood, your coding tool might actually invoke the model 15 to 20 times per prompt for reasoning and execution. So this allowance actually represents tens of billions of tokens monthly. It's a lot of headroom. So the crucial point is how you manage this quota. Because GLM 5.2 is this highly advanced Opus-level reasoning model, it actually consumes your quota at 3 times the standard rate during peak hours, which, for reference, are 1,400 to 1,800 UTC plus 8. The official docs recommend a pretty smart workflow. They suggest using the lighter GLM 4.7 model for your routine, everyday tasks to save your quota, and then switching over to GLM 5.2 specifically when you need that heavy, complex reasoning or large-scale engineering. Oh, and as a nice added bonus, off-peak usage is currently running at a standard 1x rate through the end of September. But the ecosystem isn't just the text model itself, right? All of these plans include exclusive access to their MCP, or Model Context Protocol tools. This expands your problem-solving toolkit massively. You get vision understanding powered by GLM 4.6V for analyzing your UI mockups. You get web search to instantly pull the absolute latest API documentation, web reader for extracting structured data directly from URLs, and Z-Read for natively parsing open-source repositories. It essentially turns the AI from a simple text predictor into a highly capable autonomous development agent. Finally, let's wrap up with Section 5, upgrading and getting started. So how do you actually get this running on your machine today? Well, first, just a quick public service announcement for existing Z.AI users. If you happen to be on an older legacy plan without weekly limits, those are currently being phased out. Auto-renew officially turns off on April 30th, 2026, but the good news is the migration support is excellent. You automatically receive 2 complimentary months of the equivalent new tier, plus you lock in a 50% discount on renewals for a set period. So definitely make sure you check your account dashboard so you don't miss out on those sweet benefits. Let's move to new setups and see how this builds out. Getting GLM 5.2 running in your favorite coding agent like Claude Code or Klein is honestly super straightforward. Once you have your active subscription and your API key, just drop into your terminal. Open your agent settings file, like the Claude settings JSON, locate the model routing settings, swap that string over to GLM-5.2, save it, and restart. It's literally that simple. Now, one vital detail that constantly catches developers off guard: you absolutely must configure the correct base URL. The brilliant thing about the GLM coding plan is that it seamlessly supports both protocols. So if your tool expects Anthropic messages, you use the Anthropic-specific endpoint. If it expects OpenAI chat completions, you point it to the OpenAI chat URL instead. Hit the nail on the head with this configuration, and the integration is completely flawless. All right, we've covered the benchmark dominance, that incredibly efficient MAWE architecture, the massive cost savings, and exactly how to get it integrated. But I want to leave you with one final, really important question to think about. Is your CI/CD pipeline actually ready for GLM 5.2? When you start integrating this into your automated security workflows, remember that you are unleashing a model with 40 billion active parameters per token. While it's cheaper and way more capable, you really need to ensure your local inference hardware or network setup can handle that specific heavy load without bottlenecking your downstream security checks. It's a remarkably powerful tool for sure, but it absolutely requires the right infrastructure to truly shine. So what does this all mean for your next big project? Thank you so much for joining me for this explainer, and hey, happy coding!